Hello students, welcome to class PM. In today's class we are going to learn about another chemical bond theory, that is valency bond theory. This particular theory is based on quantum mechanical model of atom and it was proposed by Linus Pauling. So let's see what is valency bond theory, how it explains where the valency shell electron pair repulsion theory is failed, how it overcomes the failures of Vesper theory. Now we will see in today's class. So according to the valence bond theory of Linus Pauling, when two atoms come sufficiently close together, when two atoms approach each other, the atoms which are having lone pair electrons in their outermost shell. Lone pair electrons means here off-filled orbitals. We know that in every orbital we can fill two electrons, but here the atoms with unpaired electrons, when they are approaching each other, the valency orbital having unpaired electron of one atom will overlap with valency orbital of unpaired electron which is having opposite spin with other atom. Once again, try to understand it clearly. When two atoms approach each other, this atom is having a valency orbital with unpaired electron and this orbital is also having a valency orbital with unpaired electron. Here the condition is that these two electrons in the valency orbital should have opposite spin. So in the spin quantum numbers we have discussed that there is a clockwise spin, anti-clockwise spin. Clockwise spin we have shown with upward arrow mark and anti-clockwise spin we have shown with downward arrow mark. So in these two orbitals of these two atoms should have unpaired electron with opposite spin. So these two valency orbitals overlap with each other so that these unpaired electrons with opposite spin will shared between these two atoms so that the covalent bond is formed. Okay, so according to the valency bond theory, the conditions for the atoms to participate in the covalent bond formation is that first condition is that the atoms in their valency shell they should have unpaired electrons. Only atoms with off-filled orbitals only will participate in the bond formation. That is the first condition. They should have off-filled orbital, which means unpaired electrons, and the atoms which are participating in the bond formation should have electrons or unpaired electrons of opposite spins. That is the second condition. And when they approach each other, what happens? These two orbitals overlap with each other. Only the valency orbital, we are talking about valency orbital. Inner orbital do not have any role in the chemical bond formation. Only the valency orbital which are having unpaired opposite spin electrons will overlap with each other so that the covalent bond is formed between those two atoms. For example, if you take the hydrogen, how hydrogen molecule is formed? So we will explain the formation of hydrogen molecule by using valency bond theory. So we know that hydrogen atomic number is 1 and its electronic configuration is 1s1. So there is one electron in its only one orbital, that is 1s. Same way another hydrogen is also having 1s1. These two hydrogens when approach each other, 1s orbital of one hydrogen, 1s orbital of another hydrogen overlap with each other so that both hydrogens will share this pair of electrons between them and hydrogen molecule is formed. So this is the way valency bond theory explains the covalent bond formation. And here another important thing we need to remember is that only the valency orbitals are formed, overlapping in the bond formation. The inner orbital has no role in the overlapping, only the valency orbital. So each hydrogen atom or any other atom, they maintain their own orbitals. Only the valency orbitals which are overlapped are shared between those two atoms. Okay, these two atoms are overlapping, these two atoms are approaching either, so the valency orbital of this atom, valency orbital of this atom are overlapping with each other. So in this, only those valency orbital which are overlapped are shared between them, and the remaining orbitals belongs to their respective atoms. Okay, this is another important factor. So if there is a multiple bonds, if there are multiple bonds between two atoms, then how it will happen? Okay, the multiple bond, whenever there are multiple bonds like double bond, triple bonds, the first bond is always formed by end-to-end overlap or head-to-head overlap. It is called end-to-end or head-to-head overlap. Okay, so for example, this is one atom. Imagine in the this is one atom and this is another atom. When these two are approaching each other, so two kind of overlaps are possible. That is end-to-end overlap. This happens through the internuclear axis. Okay, the end-to-end overlap is always happen along the internuclear axis. For example, here one nucleus, here one nucleus, and through the nucleus there is a axis. If you imagine, if overlapping is occurs across the or along the internuclear axis, that is end-to-end overlap we will call it. And through, if the bond is formed by end-to-end overlap, the bond is called sigma bond. Okay, the first bond is always sigma bond. Now the second and third bond, if we are talking about multiple bonds, the second bond and third bond is always forms by the lateral overlap. You can see in the picture how the lateral overlap and end-to-end overlap occurs. So the lateral overlap is always perpendicular to the internuclear. If internuclear axis is like this, the lateral overlap is perpendicular to this one. Means this is in the vertical way the overlapping occurs. So since overlapping is in the large extent occurs in the end-to-end overlap, because it is along the internuclear axis. That's why overlapping through end-to-end overlapping is in the maximum extent. That's why the sigma bond is very strong band. So whenever orbitals overlap laterally or sidewise overlap, pi bond is formed, and this pi bond is a weak bond, because in the pi bond formation the extent of overlap is small when compared to the overlapping in the form of, when compared to the sigma bond formation. Okay, so here we need to understand one thing, that when multiple bonds are formed, the first bond is always forms through the end-to-end overlap, that is along the internuclear axis. Due to this, sigma bond is formed. In the sigma bond formation, the orbital overlaps to the maximum extent. That's why it is very strong bond. And after one sigma bond is formed, then there is no chance for the end-to-end overlap again, only chance for the sidewise overlap, that is lateral overlap. So one sigma bond formation after, the other bond, the second bond and third bond is always forms by the lateral overlapping. In the lateral overlap, the orbitals overlap to the smaller extent. That's why these two bonds, lateral overlap bonds, that is 5 bonds, are the weaker bonds. Okay, so we need to remember sigma bond is strong bond and the pi bond is weaker bond, because sigma bond occurs through the internuclear axis, which is end-to-end overlap we call it as, and in this overlap is maximum extent, and the pi bonds are formed due to the lateral overlap or sidewise overlap, and this is happens because of small extent of overlapping. That's why pi bond is a weaker bond. And one more point here we need to remember is that pi bond is always formed after the sigma bond, because whenever two orbitals come to each other and try to overlap, first end-to-end overlap is, when this end-to-end transaction is done, overlapping is done, then only chance for the sidewise overlap. That's why the first bond is always sigma bond, and sigma bond formation after only pi bond will be formed.